Hey, hello everyone. Welcome to the Java Champions Conference 2024. So good to have you here. If you can hear me, if you can see me, say hello in the chat so we can get started with this new session here, right? I see Mary already saying hello in the chat, so that's so good. All right, so without further ado, I want to see your questions. I want to see you talking with us. I want to see your interaction because the topic today is an amazing topic. And to introduce this amazing topic, I want to get here these amazing friends and Mary Gringalski. Hey, Mary, how you doing?
Hello. Yeah, Bruno, thank you very much. And I'm good. And how are you, Bruno? So good to see you, as always.
I'm doing great. So I see here Jan. Hello from Ontario, Canada. I say Shili saying hello, Mary.
Hello.
Sebastian saying hello. Hi, everyone. So hey, everyone. So good to see you here. So guys, Mary is a Java champion, as everyone knows, right? She's a developer advocate of data stacks, right? So it's a company that works with real-time AI, big data, in streaming and cloud native systems, right? So she has lots and lots of experience in software engineering. She used to work with IBM, right? But she's most known as one of the leaders and the president of the Chicago Java user groups, right? Where she's an amazing person. She's very receptive. She builds community like no one else. So without further ado, right? So Vincent say hello, Java man. Hello, Mary. Say hello. Good to see you here. Miguel, hello from Jacareí, São Paulo, near me here, Mary. All right. So without further ado, with you, Mary Gringalski.
Thank you, Bruno. Thank you, Bruno. I should say to Bruno has been my inspiration. So without him, I wouldn't be here too, I should say. So thank you, and all the other, Java champions, the other people who come before me. So thank you so much again for the opportunity. I'm really excited today. So let me then make myself shrink so that I don't block this. So yeah. All right, so I think it should be good. I'm like tiny right now, but if I block anything, let me know. I'm also trying to watch the comment section too. So if there's any question, feel free to also ask me. I'll try to answer them as I go too. So I like to be having this as very interactive. So, and again, welcome to my talk. So I won't spend too much time introducing myself. And as such too, my topic is about, well, what other things other than generative AI? That's kind of the buzzwords of today, right? The generative artificial intelligence. And it's interesting too. And it's in the sense that why am I talking about this, right? Because I think in the Java world, it's still, AI is still not like a very friendly thing, so to speak. I shouldn't say like friendly, that might not be the right word, but it's a bit like not like, in the foreground, let's put it that way, right? We all know there's, AI is coming up. ChatGPT change all the world. So I think too, because of my work situation, I'm sort of being like, naturally kind of brought into the space. And I have to say too, I've been embracing it. To me, I think this field just keeps changing. So, and it would be very interesting. So let's spend some time talking about it today. So again, I'm very appreciative of the opportunity. Talking about generative AI, there can be many levels of talk about it, but I'll focus today to some basic information and then get a bit into the vector database similarity searches from that angle. Bear in mind too, there are many things too, so that's what I'm going to be talking about. Let me click. So this is the agenda for today. I'll just give a brief background of AI. We want to understand what the players are in this generative AI era. And then also a couple of terminologies that we have all heard about. I just want to clarify them too. I think will be good, especially for folks who may be new to this and just to understand what they mean, right? GPTs, NLPs, LLMs, prompt engineering, and then get into a bit, as I mentioned, the vector database kind of perspective too. And then explain some of these things and also show you a quick demo. If there's time to, I want to show more. So let's see how things go. And then also to share with you what I think, are really the benefits and the challenges too, and some resources. So with that, let me start. I won't spend too much time. Who is Mary? I think I already got introduced by Bruno so kindly, kind of introduce myself to you. So I won't spend too much time, but if you want to stay in touch with me, which is something I really like to do, I really want to learn from you as well. Everybody's doing different things. And so these are the things I've worked with, kind of not the only thing, but it's kind of like, if I tell people in a few words, these are the things I worked with. I'm developer advocate, very passionate. And again, you can stay in touch with me and I'll share with you my contact information towards the end of this presentation. So let's start then, a very brief background of AI. So when I was told, first, by the company, okay, now switch focus, talk about Gen AI. So to me, it's like, what does it mean, right? AI, first of all, can mean, it's a broad umbrella of things. But yet, when I first started thinking about it, and I really like to kind of get into the root of things and try to understand something from its beginning. So interestingly, too, is somebody saying sound cuts? Is that correct? Let me kind of make sure. I don't.
Yes, there's a little bit of sound cut, Mary.
Sound cut. Okay, let me kind of take a look too. Let me make sure. Yeah, right now it's okay. I think I am pointing to my particular kind of my my microphone too. Let me kind of also double check.
I think it's something that it looks like you hit somewhere, or maybe the table is a little loose because it comes and goes.
It comes and goes. Okay, I think it should be okay. Let's see. I think I'm doing it because it's let me kind of make sure it's a little bit loose. I did find out. So thank you for letting me know. So if it happens again, please let me know. Okay. And maybe because it isn't sitting kind of stable in a stable manner. So I try to like have it a little bit fixed.
Yeah, when you move when you move forwards in your chair, the sounds happens.
Oh, okay. All right, let me kind of make sure it's something very sensitive is picking up. Okay, let me make sure that I don't. So if I don't move forward, it should be okay, right, Bruno?
Yes, it looks like.
Okay. All right, let me make that mental note. And thank you again to Vincent for letting me know too, and Bruno for fixing it or telling me. Okay, so let me kind of go back. And so let's start with AI. Understand it from the very beginning of time. When did it actually start? I was curious. So what I found out was that essentially too, I think, based on historian, all these studies, they were saying that artificial intelligence started as early as 400 to 500 BC. So, and then if you kind of look to like behind, on this slide too, is basically there are two, these are like steam powered pigeons, and they were designed and developed by this Greek philosopher called Archytas. And it's interesting too. And I think the idea is that not that they are really artificial, but the fact that it's something that it basically is doing work for us. So that's where the concept comes in, right? And it's basically it takes some effort away from us, so then it's something else doing the work for human beings. So that's the point of view. And of course, it's far from true artificial intelligence. But I think the artificial kind of connotation to it is that it's steam powered, so it's not something that we have to keep cranking the mechanical arm to make it fly. It's just like it's steam powered. So anyway, so fast forward, right, to kind of the near old times, when basically AI started coming along was kind of in the 20th century, when it's kind of started to become more of the thing, and it's kind of, if you trace back to the current state that we are in, can go back to like 1930s, 40s, when the golden age of science fiction came out. And I mean, human beings are full of imaginations, and kind of there are always people kind of looking into the future. So to me too, like this is a diagram that I've found, on this website that I've shared in here. And so if you're interested, you can take a look too. I think it's always good to understand some history behind this whole movement, right, of things. And the idea is that really we wanted to basically delegate, some of these tasks, for somebody else to do it for us, non-humans to do for us. But the thing is too, if you kind of look, right, to me, I'm thinking 1950s, of course, the father of modern computing, Alan Turing, kind of essentially asked the question, can machines think? I think that's when really kind of sparked the interest of a lot of research community slowly starting. And then all these things, as you can see, these are just highlights of some of these activities. DARPA funds AI at MIT, all of these things. And if you keep going, many things. And then Deep Blue, I work for IBM, so that's also was interesting to me. When Deep Blue was developed, but of course it was kind of early form of more like supervised kind of training, right? Kind of training the bot. And so that eventually, beat the chess kind of king of that time frame, which was Garry Kasparov in chess. So that was kind of something interesting. I just thought I'd share this with you. So anyway, so now kind of look a bit too into AI. It's basically all about automation. Again, it's about a time period in which, we're kind of investigating these different ways of having machines do the work for us instead of us. So let's also take a little quick look to, this is kind of a very famous kind of, kind of diagram that represents the concepts of AI. So they're essentially like a circle of like different layers. So essentially, too, AI is like the umbrella kind of concept that surrounds this whole thing. It's basically AI wants to mimic, the intelligence, or the activities, the behavior patterns of human beings. And essentially, too, it's something that's kind of fabricated, not like humans doing it, but we want to have some, ways of imitating human beings to do things. And of course, on a much more, efficient kind of manner. So if you kind of look a little bit deeper to the next layer of this onion will be like machine learning. So there's a difference too. Machine learning is basically you get more into the center of it all. It's basically the techniques, that enables us or enables like computer to learn to think. And then basically too, it's not even like us having had to lay out any specific rules for it to think. It's basically let the computer, let your programs look at the data and figuring things out on its own, so that's kind of like innovative in that sense, right? So you essentially too, you give it data and then and it's based on training a model from data sets. So that's kind of like a bit kind of still higher level. It doesn't really get into all of these deeper things. So that's when you kind of get into the center of it all is like the deep learning. Deep learning is essentially too is involved, mimicking how the brain, our human beings, the brain, the neural system works too. So this is where all of the neural networks, all of these things kind of come out of, right? And it's essentially too the technique to perform machine learning that's inspired by how our brain's neural system works too. So it's pretty interesting. And that's where all of the current generative AI, the LLMs, and I have another diagram that kind of describe it in a pictorial format. So let's kind of take a look too into this generative AI era. And what is generative AI, right? Quick, first of all, is a disruptive field in AI. Disruptive in the sense is that there's no longer required us to prompt, to kind of send commands to the robot or the computer to ask the machine to do work for us. We can basically ask like how we talk to another human beings. So that's a really like a disruptive in that sense, because if you think about it, right, we are used to, ever since we're little, we started, or not just little, but when we first started computer learning, we actually have to learn some rules, that are very specific, right? And sometimes too, some of the way how you ask question is very cryptic, it's kind of strange, and all of these things. But now with Gen AI, there's no need to, right? So there's no longer needed that you say, okay, help me with this. And then I want to say dash, for example, like you do a bash script, scripting is you give it some flags, some parameters. You say, how many times around it, and then 10 times or something like, for example, like that, like a parameter, list of parameters. In this case, you basically can just talk to this computer like you talk to another person. Now you can say, well, I like to, look for a house that's got 4 bedrooms, that has like, 3-car garage and all of these things, and then let the computer program figure things out. So that's kind of generative AI in that sense. So it's disruptive, and it's basically, it generates the contents that you're looking for based on how you ask it, basically based on the prompts, right? These are called prompts. And how it works is basically a combination of the machine learning and deep learning kind of algorithms to produce the contents too. Now, a word to kind of point out is that Gen AI And actually, before this too, that this actually before GenAI was predictive AI, as we are all aware, right? But predictive AI is slightly different in the sense that, or at least one aspect, if you could think of it, is that predictive tends to be it's learned from the data, but then it's based on usually, questions such as, well, can you predict, what is the economy like, in the economic forecast in 2 years, 3 years, and then weather forecast, in 5 days or something like that. But then for generative AI, it tends to focus all of these contents on more like artistic and creative side of things too. Can you write me, a blog article? Can you design a dress for me? Can you figure out this song, who is singing it, and all of these kind of amazing things. So that's kind of like the difference too. And then also to predictive AI tends to be the content will expire after a certain period of time. Like you have business forecasts, for 5 years. Once you have reached that 5 years, then the content becomes obsolete. So. Okay, I think I see a question. Is it from Vincent? I remember the first chatbots that you could program in Oracle Cloud in 2018, where you had to create answer scenario. GenAI disrupts it. Oh yeah, disrupts it heavily. Of course, it wasn't even using that it wasn't even using the techniques it is now. There wasn't any like LLMs and things like that, and all of these things that it is doing. But good point, Vincent. Thank you. Okay, so that's GenAI. But let's kind of really quickly also take a look too. With the current generative AI, right? When did it start? Kind of roughly speaking, we can say in early 2000s, in the new millennium. 2003, that was the Joshua Bengio and his team developed the first feed-forward neural network language model. So that's not like exactly what we have today, but it really planted the seeds, right? That kind of leads to where we are. And 2011, basically, that's things that have been brought to the masses was Apple's Siri. And so that's actually making use of the NLP assistant to do that too. But as you can see, it's kind of specific for that particular product. It's not something that you can, it wasn't like a general model that can be used by anything else at that point, but certainly a big milestone in this kind of march towards the generative AI to where we are today. And then 2013, there was a Word2Vec, and that's kind of like really the early form of where it is the vector search, for example. And it's basically using like natural language processing to kind of, also uses the neural networks to learn the word association from a large set of text. So much of it, of what the generative AI now is doing is that based on some text input, is trying to make some word association. So that's kind of like the very initial stage of this Word2Vec. And then 2017, and if some of you are already familiar, right, have heard of this phrase, attention is all you need. And that's where that phrase came from this group of researchers in Google with their research with the new simple network architecture called the transformer. So that's a bit of a background about this, generative AI thing. Okay, so before we kind of go on further, I thought it would be good to kind of point out some of the players in the Gen AI era too. So there are generative models, as we know, right? These models, it takes a lot of time to train and it's very expensive, this so-called foundation model. So and then, of course, too, all of us are familiar. Everybody's hearing about OpenAI. It's kind of more like a consortium of many companies kind of funding all of the research, all of these things. And OpenAI basically came out with all of the GPT models, and now I think we're still in the GPT-4 timeframe. But then there was the most disruptive, that came out was really GPT 3.5 when ChatGPT came out, right? And it was ChatGPT is more the generative app that makes use of the GPT 3.5 in November of 2022. And so, like not too long ago, it's pretty amazing. All these things pop up since then. It's really kind of caused quite a bit of a big kind of an draw all the attention of the whole world. So these are models, right? And so some of the models, for example, I just want to highlight like Llama. We know that they came from Meta. And then also too, there's also a BERT. I want to point out BERT is an early form, from Google, right? That's the BERT model. And then there are also then codecs in here. I want to point out essentially too is what Google GitHub Copilot is based out of this particular model to kind of do coding, right? That type of model kind of in there. And then there are also like, image kind of models too. It's like text to image, like diffusion model. All of this is basically stable diffusion, and that led to like Dolly or Mid Journey. Those are example. And then also too now, with Google, it comes out with Gemini. Is quite more recent. Is the multimodal type of models too. And then there's also Whisper, which is more deal with audio. So just bear in mind, these are just sample. A couple of the popular models are more well-known ones, but there are tons of other models too. So. And now then take a look too at the generative apps, right? The apps that are leveraging on all those models that I just showed you. So first and foremost, ChatGPT, again, the 3.5 that came out, well, ChatGPT that came out based on GPT 3.5, that's kind of disrupted the world. Everybody knows it. And then of course too, then there are others like Bard, that's kind of catching up, right, from Google, and Bing AI from Microsoft, and all of these. And then the other, like Monkey Learn, for example, is a text association low-code type of apps too. That's kind of appear to be popular too, I think, with some business. And then there's also GitHub Copilot, which I also mentioned about, and that I think for developers, that's kind of most of us know about. And then the others are more like SEO AI, Salesforce AI, all of this Notion. There are other companies that also do their own apps that are kind of making use of all of these popular models underneath the hood. And as a word I like to kind of point out is then this generative AI era. So the thing is too, is that I think it's easy to understand we can do text to text, right? It's more like you ask a question in a chat bot, and then you ask something and it comes back in an answer in text kind of format. But the thing is, what is making it even more useful is basically doing like multimodal kind of mode. You can be like, for example, the example I gave you, like you can say, I'm looking for a house with 5-car garage, the 10 rooms and all of these things, and a patio, all of these things, and then it will come back, right? Then do all the searches for you, came back with the houses that are on sale in your neighborhood, for example. So those are kind of really creative kind of usage of this type of applications, right? So that will be very useful. Or you can play some music and then have it tell you who is singing that music, right? Or show me the picture, or show me the video, like this. All of these like intermodal kind of interactions will be really kind of value added too. And you can also have it design a dress for you, or kind of and also at my company too, there's the group of solutions architect to develop an app that's basically look for fashion. I show the bot a picture. Can you look for a similar fashion for me at another place? And they will go and shop around for you and send you a bunch of links, of where you can look for, other similar type of fashion, things like that. So, and of course, not to even mention there's code too. You can be telling it, okay, I don't want to be writing a lot of the boilerplate code, especially. You can just basically ask like GitHub Copilot, for example, write me some code, sorting algorithms, all these things. And three-dimensional is another modality that it should be supporting as well. So, and then how about, people, right? We talk about the models and the apps. So there are basically two data scientists, computer vision engineers. They're dealing with more like the what, right? The more like the subject matter. They're a subject matter expert, what it should be, what data is supposed to come up with, what kind of model like that. But then it's basically too, they are not the ones that know how to implement it. So, and especially if most of us, I assume, are developers here, we are the ones where the data engine, the new AI engineer, the software engineer, the ML ops, dealing with machine learning, DevOps, for machine learning type of purposes. You want to be able to do like quick deployment when the model, you can also have, so to speak, like any kind of model changes that are needed, and now I actually have to also bring in another terminology, which I'll touch upon a little bit, called RAGs, right? Retrieval augmented generation, this design pattern, this architectural pattern that can be implemented in many ways, but basically too, that can help with filling in some of these real-time data that's not already inside your static big chunk, LLM. So you can be doing all those things, and it's basically relying on new ways of machine learning operations to help it to do quick deployment. And at least that's the theory. I don't think anybody, or not many places, as I'm finding, have true kind of like real-time machine learning ops yet. I think that's an area that will require a lot of, or not required, that will have, kind of a lot of opportunity there. So, okay, so that's that. Okay, so now then, after this, talking about all those, let's kind of get into this terminology, right? The generative pre-trained transformer, GPT. So the GPT part, what is it, right? So that's what is basically starting to kind of let you know what are the, high level wise, what are the things that are making things happen. It's basically the GPT. They are pre-trained transformer. So to speak, transformer, it transforms. So what does it do? It takes like simple prompts, right? That's kind of natural human language, and that's the big difference as input. And then it does what is called like pattern matching, or it's basically what it is also called, it's called similarity searches. And it answers questions too for the prompts too. So it produces, and the amazing thing is now it can produce contents. You can write an essay. I think we're all already kind of been fascinated by it, that, you can ask ChatGPT, please write me a blog post about something. It will generate that whole blog post for you in a computer program, right? And all of these things we kind of know. So these are like transformer GPT. And then in just a bit of a background information, it started showing up, around 2018 too. That's when like GPT, there was a paper on GPT by Alec Redfords about this language model. He published that on OpenAI's website and showing how the generative language model can acquire knowledge and process dependencies, unsupervised training, right? Based on pre-training on, again, the training is on a huge, corpora of text data too. So since that came out, then GPT-2 also kind of came out in 2019 from OpenAI. And then slowly too, I think there were a lot more, kind of upgrade right now. Then it gets to GPT 3.5, which was November 2022. So it's just within like 3 years or so, it came out with the GPT 3.5. That's kind of shocked the world, essentially. But the first two before that too, in 2022, that's when Stability AI developed Stable Diffusion. And that's like diffusion-based image services that kind of came out in that time period as well. So such as like Dolly, I mentioned already, the model Dolly, Midjourney also came out during that time too. And then 2022, that's when end of year GPT 3.5 got released, and it's an AI tool that reached like 1 million users within just 5 days. So the rest is kind of like history. We know that the world is moving fast, and now, a lot of companies are taking advantage of it. The big companies are all doing it, like Google, Microsoft, I mentioned about like Bing, AI, Bard, from Google, all these things, these are just kind of a small little handful of what's going on in that, in this area. 2023 as such, last year that came out, OpenAI came out with, a new browser extension for ChatGPT as well. I think there are already like tons of new things that are popping up. So that's kind of GPT. And let's kind of take a look into natural language processing. What is it, right? So it's basically an interdisciplinary subfield of linguistics of computer science. As such, too, it has to deal with languages. How do you process languages? And so this kind of gets into all of the nitty gritty of what languages are, how it is, linguistic side of things. And essentially, too, it deals with how to process like natural language data sets, right? Huge sets of data. And it used like rule-based or probabilistic machine learning kind of approaches to kind of process it. And then essentially, too, it enables computer to learn from contents too, not just kind of word for word, so to speak, right? And you be able to also kind of figure out the contextual and nuances, of the language itself. And that's what is kind of pretty disruptive in that sense. And of course, too, you do have to know too is that all of these things are not like strictly, again, one-to-one kind of matches. A lot of times you're doing all of these searches, it's basically making predictions of what it should be for the next word, for example, things like that, right? So again, these are just very high level kind of understanding, but we can rely on NLP being kind of like the thing behind, that kind of making all the magic happens too. And it's essentially too, you're not just like looking at the languages, but you have to have it really true, having some ways of predicting things, beyond what we can do on our own. So now then leads to the next thing, which is LLMs. And that's what developers like ourselves, we're kind of mostly kind of interfacing with all the time, are LLMs, right? It's a type of machine learning model. And it's also what is called foundation type of model. And it takes a lot of money and time to process, as we know, because it takes in like petabytes of data, even bigger too, of data that it churns through, making all these associations and then forming all of these things inside of it, right? And so it takes a lot of GPUs, and also, like, not just one GPU, 5 GPU. I'm talking about thousands of GPUs that has to be processing, right? A lot of maybe heavy processing, parallel processing, computing kind of thing to do it too. So it's not for like ordinary people like ourselves to do it, because that's just not possible. It's very expensive. But the thing is, though, what it does is that it performs tasks like on the NLP kind of level. It leverages on the NLP kind of techniques, and it generates and classifies all of the text, and essentially answers questions. These are answers prompts, just like a human being, and analyze the sentiments, chatbot conversations, all of these. So large language models is what we work with. So we kind of look into this from more like a conceptual level. So you can kind of take a look right here. Earlier I talked about high level wise with the artificial AI, this whole thing, and then machine learning can deal with unsupervised, supervised, or reinforcement learning. And then basically you kind of go deeper, is the deep learning part, to deal with this one is the neural network kind of layer. Deep learning starting to get into neural networks, and ANN and CNN is concurrent neural networks, and RNN is recurrent neural networks. So CNN is actually better for images, for example, and recurrent is dealing with, I think, more kind of like recurrence, kind of more processing type too. And so these are, if you're interested, you can get into all of these details, or deep learning. But the thing is too, as you can see, GenAI, as we talk about it here, the different techniques, the GAN, the VEI, and the transformers too. So that's when, like, image generations are the GAN and the VEI, and then LLMs are the transformers in here. And behind the scenes, LLMs are performing all of these NLP tasks too. So it involves a lot of data science involved, because there's a huge chunks of data. So all of these kind of interplaying with one another. So now then, okay, let's kind of get into, without getting too deep now, let's kind of get into how can we work with LLMs, right? We're developers. So now these are kind of some of the example of the popular LLM kind of framework. It essentially allows you to develop, apps with working with LLMs. And so first and foremost, and if some of you are familiar too, is LangChain. Unfortunately, LangChain by itself is JavaScript and also Python. So for Java people, I think presumably a lot of you are more come from the Java side. And kind of like, don't be disappointed, because next slide I'll be showing you to how you can work with, from the Java perspective. But just wanted to share with you, right? So say Llama 2, this comes out of Meta. Actually, I should say over here too, Llama 2 is more of a large language model too. And then it also has interfaces with it, right? And it's basically, there's also Llama Index too. That's another library that's very popular too. And also Palm. Palm is from Google that can work with their Vertex AI. And then one more thing I wanted to share with you is Hugging Face. Maybe some of you, if you're already kind of playing around with it, you're familiar too, because it is kind of think of it like GitHub, for code, but this is Hugging Face is another hub for more AI. You can find a lot of models that people have trained and then share with it there. And then a lot of examples of these. It's sort of kind of, again, like a GitHub, but for AI, generative AI type of kind of usages too. Let's then take a look, right? We're Java. I have this special slide for Java side. So the thing is too, first of all, just wanted to show you, there's one called JLlama. It's basically Java kind of that supports Llama, the model from Meta Llama and Llama 2. And then it also actually supports GPT-2 and also BERT 2. And I'll quickly show it to you if there's time to, because this one is all open source, by the way. And it's actually developed by Jake. This is handled at GitHub and JLlama, if you're interested in looking at it. And he's actually working on making it more GA ready. But at this point, it's still kind of beta, so you're welcome to look at it. And like I said, I also took it and play around with it. And I have to tell you, it's funny to share with you, because I was like, okay, it can do GPT-2. So I kind of downloaded the GPT-2, like a small size, model onto my local machine, and I ran it. And I was asking some questions, but it's funny, to GPT-2 level is that it has a lot of hallucinations, which is like it doesn't know the answers and it gives you back wrong thing. And was like, oh my gosh, it's like so funny because I was asking about some beetles and then it came up with some other things. It's completely like, what? What are you talking about? It's kind of for a good laugh. I think it's kind of fun, but just FYI. Okay. And anyway, then the other library is called JVector. Now, this one is a bit more of a lower level thing. And this also is developed by our, okay, so first of all, actually, before I go forward, I should have said JLlama is developed by Jake, and Jake is the chief architect at DataStax. So this is his open source project. And then another open source project is by Jonathan Ellis, and he's the technical co-founder of DataStax. And so he's kind of very familiar with Cassandra, all of these things and all of these low-level stuff. And he gets into it. And basically, JVector is make use of Project Panama, as you know, and all of the vector API. And essentially, too, is what powered Cassandra database to make it very performant, especially for doing vector level type of searches, making it really scalable and all of these things too. So that's JVector. So I also share with you here. So, and also the thing is that it came out in October, and then there was like a week or two, it was the #1 repository for a bit too. So there's garner a lot of interest into it too. So that's some information about that. Now, another kind of more like general level of libraries that you can consider using is LangChain 4j. So as such too, LangChain 4j is not directly affiliated with the LangChain I talk about, but it's more like, another group of folks who are doing this as an open source project and is Java based and is based on kind of the LangChain type of model too. And you can consider using that. And then there's also Llama 2. Llama 2 is direct port from Llama C, the C implementation of Llama. So, okay, so that's that. And let's kind of like, let me, before I kind of talk too much, let's get into the vector database and vector search. So again, there are many things to talk about if we kind of talk about GenAI. But another thing, just kind of important, very important too. Now, this is something that my company, as such, DataStax is really a data company. Started off with supporting for, Apache Cassandra. Maybe some of you are already using it. So as such too, last year, the company 2023, because of all of the generative AI needs, for vector data search. So our company also immediately actually was quite fast. I was pretty impressive. I think it was in June, came out with support for vector database in our managed cloud platform called Astra. And then essentially too, the changes to support vector database kind of got contributed back to Cassandra. So the Cassandra 5.x, the latest version, finally it's got the all of the capabilities of vector search in there too. So our company actually did a lot of work to support that contribute back to Cassandra. So, okay, but first of all, without all this stuff, let's kind of generically talk about what is vector database. It is a purpose-built database that serves up vector data type. And why is it necessary? And as you can see, right, for generative AI, we're talking about data that's not single dimension anymore. What does it mean, right? So if you kind of think about it, right, we are kind of, our minds are so used to being trained to think of data as single dimension, like the one dimension side. I mean, it's very sufficient, don't get me wrong. We've been doing it for quite a long time. But in reality, though, we know that, as software needs to become more complex to support, more sophisticated type of usages, such as in this case, generative AI, all of these things. And there exists a new type of data to support this. So that's when the birth of this support of vector database type that comes out. It's not all brand new, but there are already some other vendors, quite a few, in fact, that's already started doing it even before the generative AI kind of arrived too. But again, our company just came out in June of last year. So the thing is too, what makes it work is basically there's this concept of the embeddings. The embeddings, what are they? They are essentially that kind of essentially embeddings are a translation of all of your data into like numerical representations that can be stored inside the vector database. So let's say, for example, I have a string that comes in even over here, for example, an automatic feature engineering that comes in. So I can parse that, and it's basically each word, will get translated to a number, a floating point number, and will be stored, in that particular dimension, so to speak, right? And so of the embeddings. So essentially, to N, automatic feature engineering, they each have a numbers that kind of represent them, and then they get stored, as an array of floating point numbers in your database. So then there's a new kind of column that basically holds kind of this set of data. So now you might be asking, like, why is it like that? The reason is that, now we want the Gen AI capability to be able to search for information, based on some strings that come in. That particular string that comes in has to kind of you have to look for answers too, right? In your storage side. So the storage side is already stored. So in other words, if you need to store the data, first of all, you have to determine a specific model that you need to use. Now, very common these days are using OpenAI. It has its own specification. You can use their embedding specification, the model, to do it. Or you can also use other ones too. For example, Cohere also has their embedding model too. And this is kind of another kind of famous company, I'd say, to do this kind of LLMs and all the embeddings. And so the thing is, though, you have to make sure that how you store the data and how you're going to be querying it, they have to be using the same model too. Otherwise, that won't work, right? Because otherwise, it has different ways interpretation of what the numerical representations of your words are, kind of like that. So in other words, now, you kind of understand a bit then about vector database. And essentially, too, it will need to be able to do searches when you kind of want to search for something, right? All these data comes in. How do they store, right? They are stored as vector. So now, if you are a math person like myself, I was actually a math and computer science major. And actually, I was actually very happy as I kind of started to learn more about Gen AI. I remember that was back in October or September. I was like, oh, this is cool, because I actually took classes in linear algebra. And back in college, right, I was like, okay, I still remember. It was like, well, I do all these matrix mathematics. It's fun to do, but how do we use it? That never kind of occurred to me what it could be used for. But of course, back then, there was no generative AI type of applications. But the fact is that I have that foundation. So now coming, kind of this many years later, and I'm like thinking, wow, I'm finally actually working on a, software that's actually inside of it is making use of linear algebra. So all of these are like math. And essentially, too, don't worry about understanding exactly, but the purpose of such the linear algebra is to help you to find, what is the closest neighbor of, the data that you're looking for. So essentially, to this technique, the algorithm is called approximate nearest neighbor. ANN is basically the technique you can use. Now, that's not the only algorithm. There are others too. For example, KNN, you might have heard of, and also HNSW, hierarchical neighbor. What is it? I keep forgetting. But anyway, that's actually what is the HNSW is what is being used by Elastic, in their Elasticsearch too. So just so you know, and even with Cassandra, I think with our database, we used to be using HNSW until, JVector comes in and then it's using ANN, this approximate nearest neighbor. Is essentially specifically too is the Microsoft disk ANN. That particular algorithm is proven to be very fast, So that's what Jonathan uses in the JVector too. But just kind of these are the information for you. So now, let me see the time. Okay, I kind of get excited talking about it, but I basically could also spend more time. Maybe in next talk, that's what I should do, get deeper into this vector database, really getting into some of these inner workings. But to give you an idea too, now kind of think of all the data. If you kind of look at all the data, and they are essentially, if you look at them, they are two dimensionals. These are the vectors. Some of you may be already aware, right? Vector data, what is this? What is that, right? It's no longer like the scalar value. It's not just like 1 or 2 as you plot on the graph. It's basically, it has what is called a direction associated with it. So that gives it the multidimensional flavor to your data. So for example, an embedding model transforms the text into a vector, call it embedding. And the embedding can be however many dimensions. And right now, OpenAI's embeddings are 1,536 dimensions. But the thing is, kind of, then how do you search for it, right? So let's say V1 comes in as some data that's stored, is on that point, in this two-dimensional space. That's vector 1. And then vector 2 is over there. And then you may have another string that comes as the query string, right? So the V3 is here. So I'm trying to look for the closest. Then basically V2 would be closer to V3, for example. So that's how it determines. So inside it, there are lots of algorithms, right? All of the math that's happening to kind of search for that particular point. So that's another example of this, is giving a bit more of a realistic example. That it can be a word such as cat, dog, and a house, right? For example, right? So it captures the essence of the word or a block of text within its context. And so these dimensions, how are they kind of end up being there, is basically a result of all of the LLM training too. All of these embeddings are kind of being like sorted out. And if you think of it in spatially, that's what it looks like. So that's how you can look at it. And each vector represents some words essentially. But as you can see too, in reality too, for a very complex application, these are just this is just a baby example of showing you 3 things, but this basically can be petabytes of data that's spread out in this vector space too. So as you can see, there's a need for something very powerful in order to churn through all of these data and look for what you're trying to look for too. Okay, so just another kind of diagram to kind of explain vector store and vector databases. So these are embedding storages that are with or without metadata, depending on the database too. And then there are built-in algorithms, as I kind of talked about already, nearest neighbor kind of embeddings. You need to try to find who's closest to the point that I'm searching for. So they are, for example, JVector, HNSW. And so basically, vectors are a new type of database, data that's supported in established databases such as DataStax. We have AstraDB, Cassandra is an open source database. So as you can see over here, I won't get into all the details. It's basically there are different layers too that it kind of narrows it down and look for the point that's closest to what you're looking for. Okay, so that's that. Okay, I know that's a kind of a mouthful of things, but just to also give you an idea too, vector embeddings can be used for multiple things too, not just for similarity kind of searches, right? And essentially too, when you're doing a query on a vector database, it basically comes back, with a set of information that can be the answers, but it will also be ranked by the relevance too. So when you do query, you basically have to say, what is the answers that I can search for. You can limit essentially that range of results that you're looking for. Maybe you can say I limit answers to only 1, so it will look for the closest one for you. But if you want to say limit 5, then basically the 5 top closest points will be returned to you like that. So that's vector searches. And there's also can be used for clustering for recommendations, like product recommendations, anomaly detection, diversity measurement, and classification, where all your text strings needs to be classified by their most similar kind of labels. Okay, so basically too, let's also kind of point out too, the problem, you can also use traditional database. You may be asking, well, can I use a normal kind of like the database we're so familiar with, like relational database, for example? Nobody is stopping us from using anything too, but also try to understand that we're now talking about data that's multidimensional. So traditional database would not be able to handle that dimensions, or if you want to do it, nothing, again, will stop you from doing it, but you probably have to do a lot more kind of like roundabout ways and doing all of these calculations. And I bet by the time you figure it out, it's probably not worth it, because even when you go into the runtime to process the data, the searches, it will take much, much longer than what you would expect from using a properly kind of right tool for the right job, which is a vector database. So okay, so now this is an example too, kind of more high level, kind of giving you, and kind of now we're in the GenAI kind of world. So how does it sit, right? So behind me is this database. It's basically storing of all of the embeddings, and you can see too, it provides all of the vector data. It can also augment, using the RAG type of approach to do it. The RAG AI apps can provide you with, let's say, real-time data, or maybe like domain-specific, like let's say I'm a law firm, I have additional data that's private to me. You can basically supply that external data external to the LLMs to kind of augment your search results too, like that. And as you can see, there are prompts that comes in, and a lot of data scrubbing. You need to fine tune all your prompts, blah, 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 doing all of these things, doing the embedding services, translating all of your prompts and all of these stuff. And essentially too, that's why you would kind of rely on a storage, because let's say I'm doing chat, right? So normally you can write a chat service, and actually I'm looking into a chat service with Quarkus too. Now by itself, it would do its job well, but what if, your chat service goes away, then all of your previous chat history is gone. So that's when you want to consider using like a vector database that can help you store all of your history, so you can go back to it, for example, keeping state information, that type of stuff. So as you can see, then after you process all of these things, and then it goes back, all of your responses will go back the other side and send back the augmented response. So that's kind of like how it looks like conceptually. This whole kind of Gen AI kind of scenario looks like in today's kind of popular type of applications. Okay, so now let me kind of really quickly, I think I still have maybe like 10 minutes or so, something. So I won't kind of wasting too much of your time, but we'll kind of quickly show you. Let me kind of do this too. I actually, in my slides too, which I'll be sharing with you, you'll be able to also find this link, how you can sign up for, let me kind of make it bigger, sign up for the data stacks, right? We have vector database, and we offer it to you 25, like a free tier, $25 per month for you to use for mostly your personal projects, or just like smaller type of data data set that you want to use. So now, again, I'll share with you the link, but essentially too, you can go to, it will lead you to the page, and you can quickly do a sign up. The sign up in here is that it doesn't require you to give your credit card number, which is nice. And so over here, so you can give your first name, last name, and then an email, and then just make sure you agree to the terms, and then you can sign up, and it will be up for you, as long as there's no delay, it will be up for you, within a minute or so, or even less sometimes. But in my case, I already have an account, so I'll go in here and sign in with my Google account. And you'll see that then the portal, the interface will come up, right? So on the left side is basically list out, your organizations. And then basically too, we also have Astra streaming. And so if you're interested in using Pulsar as your streaming, it's also there. You can kind of all kind of together with the $25 free tier. And let's say you use it all up, then the next month you get another 25, which is really nice too. And also wanting to point out, if you're using it for small projects, it's actually very sufficient too. And then you get another 25 the next month. Now, the thing is, if you are a startup company, you're like, oh, I really want to continue using Astra. We want to build a POC. And actually my company too also offer you what is called like a starter. If you qualify for it, you can get a starter pack, and you basically a low fee to start with, and you get a couple months that will include usages as well as like support too from us too. So bear in mind, if you need it, please let me know or contact someone at my company. So let's kind of go back in here. I want to create a vector database. So over here too, you can say create vector database. And basically, you can also create serverless, a non-vector, which is the normal kind of Cassandra behind the scenes Cassandra without the vector support, or you can just do one with the vector. So over here, you can say, in here, JChampions JChampions database, and then I want AWS or Google Cloud or Amazon or Azure from Microsoft, right? So these three kind of like the popular hyperscalers are there. And then let's say I want, North America AWS, and I create. And so that's as simple as that. However, in this case, it says database limit reached, because in my account, actually, this particular one, it's only allow one, So in this case, I can go straight to it. It's already been created. I have one created on December 23rd, is an Azure database. And as you can see, this will lead you to this interface. And as you can see too, there are database ID and API endpoint, all of these, you generate token, all of the region, everything is already kind of there. And also some basic information about the metrics, so how many requests you have so far, all of these reads and writes, all of these things. So it's actually quite good. And then also too, in the terminology is that, there are tables, right, in normal relational database, but basically in the GenAI, in our interpretation, is that we call these collections. These are collections of vector data types, tables with vector data types too. So I already have a couple of them created, but let's kind of take a look kind of quickly too. Let's go to the view all creations, collections. I'm sorry. And let me see who else. Somebody saying something. I'm sorry, Vincent. Yes, you were asking what is the max dimensions that you see for a vector in your work. In my case, I do have to admit I haven't had to do a real production one, so right now the 1536 that dimensions work well for me. But I think it is very true. Maybe if you want to scale it, I think there will it's basically we can figure it out too, basically. And Rodrigo, hello, thank you. Yeah, and don't worry about it. I think I did the same thing yesterday. I wanted to watch, but I was so busy. But yeah, but the good thing again, everybody, all of these talks are being recorded and they are stored on the J Champions YouTube channel. So anyway, thank you. Okay, so here. Let's go over here, right? So I already created one called Luxsoft call, and we are devs. These are just happen to be different conferences I spoke at, but let's say I want to create a collection. So you can just say over here, JChamp, I can do a JChamp collection, and then dimension over here. Let's do the 1536, and the example model is from OpenAI, the text embedding ADA model 002. Now, there are others too, but right now, these are the ones we support. For example, these are the ones that you can see, right? The BGE and the GINA one, or, the small, the medium, the large, all of these, and Comninos, too. So let's say we want this one, ADA. And the metric, and just to kind of like give you some idea, right? So the different metrics are essentially method that you can employ for doing, behind the scenes, which method. You can use cosine, similarity, or dot product, or Euclidean distance. And they each have their own advantages and all of these things. So now I won't get into all of the details here, but let's say we want to use dot product, and then I can just quickly do a collection creation. Oh, I kind of realized that it's already, time flies when you're having fun, right? There's so much in here. So essentially, let's kind of take a quick look. Now, I won't kind of have time to get into all of the details, but as you can see, you can kind of quickly, see that the collection is created, and then you can basically select a file that's contain all of your records that you need and immediately import in here too. So now at such right now, I actually don't have a specific files for this particular dimension, so won't do it. Although over here too, you can download sample data sets too. So this is really nice of our this interface. It's actually quite new even for me. So there's a CSV file with movie data. So let's try that. Okay, that one, and it's movie OpenAI 100. Kind of records in there. So let's kind of load it up, and then basically you can immediately view it too. So yeah, will take a bit of time, 3.5 megabytes. So it didn't take really that long, but as you can see, so you can quickly then already see the data that's in here. And then the embedding, you can take a look at the text right over here. This particular is, the title is Beavers. Beavers, and basically the review text is timed to be just long enough. And then the embedding, see, this is what is interesting, right? These are the actual data that's being stored in the vector column, right? And it is, bear in mind, it is an array of floating point numbers. So it wouldn't mean anything to you if you just look at that set of data. It's just tons of data if you kind of take a look. But as you can see, this is what it is. So you can do low data, or you can also, another thing you can do too is basically use what is called CQL console. So this is the Cassandra query language console. And it's basically, it's really convenient too. It's kind of opens up inside this portal, and then you can use SQL. And SQL, that's C with a C. But guess what? The nice thing about it is that the SQL and the familiar SQL, the Cassandra query language, is very similar. You can do create table, pass in all the columns, and then do select is pretty similar too. So anyway, so this is how you can do it. So let's say, actually, let me make it bigger. I realized. So again, there's also, I have my table space called vSearch. It's already created. So over here too, you can actually do like start from, let's say, the system schema, for example, right? And oops, actually, you know what? I didn't even do it like that because I didn't actually give it vSearch, because you have to say vSearch, I think. Oh, no? Okay. You know what? I think it's a schema. Actually, that's another thing. The other day I was doing. Okay, so I kind of it's my fault. There's like specific kind of syntax too, and I realize my time is short, so I don't want to kind of go and then look for kind of special thing. Oh, actually, you know what? I know what to do. There's also a. Uh, I think there's key spaces to maybe is it system schema dot key spaces, I think. Yeah, there we go. Okay, so this one I do kind of get it. Okay, so key spaces essentially is a Cassandra specific thing. Is think of it like namespace. So system schema is what holds all of the metadata. So that's what I was trying to kind of show it to you. And essentially too, you can kind of see in here, the V search is what I created for the user space, for example. So, okay, so this is just an example that you can basically make use of the CQL console to do the work for you too. So this is kind of a very quick kind of taste of what it looks like for using this vector database. And in fact, let me go back, because of the shortness of time, you probably want to go to the other talk. So let me kind of get back in here. So if you want to, again, I want to invite you to kind of, to basically, let me kind of not block this QR code. So if you want to sign up for the free tier usage of the Astra database, please visit this short link or scan this QR code. And if in case, you didn't get it today, I will be sharing with you the link to my this particular slide deck. Then you can get the links to everything else too. So okay, so really quick before I end, it's basically benefits, right? So basically, think of this Gen AI thing is like you ask. All you need to do is just ask. Isn't it nice? Ask like you just talk to another person. No need to know the rules of asking what is the parameter name, what's the parameter value. Just talk like you do to another human beings. So basically, you just have to make sure you ask wisely. So make sure your prompts are correct. If not, fine tune it, right? So and challenges, though, they're not without challenges. You have heard of the terminology hallucination. So if you're basically if your particular LLMs doesn't have all of the information, then it will come back with wrong answers. That's what hallucinations is. Now, there's also another point. We are all aware there are ethical concerns too. There can be potential misuse. This is opening up to many things. So make sure we use it wisely, use it correctly. And then how about real-time, up-to-date data? LLMs are just a static chunk of huge amounts of data that's been trained. But what if it picks data from 2000 up to 2021? Then you're out of luck if you're trying to search for answers that are in 2022 or 23, right? So that type of stuff. So that's when you want to consider using a RAG pattern to do your work. Okay, resources. So with this, I'm coming to the end, and in slide deck. This is the my slide deck if you want. And then again, I'll be sharing with the Java Champions conference too if you miss. And thank you so much, Sebastian, James. Thank you very much. I know you want to go to another session. So let me real quickly step through. These are different resources. There's also a data API that just got released too. And I wanted to share with you too. I will be doing a series of live stream too. So please follow me on my live stream. I have it on Twitch and multi-stream to also my YouTube as well. It's either Wednesday, Thursday, or Friday afternoon because it varies. Sometimes I'm just too busy. So please follow me on my Twitch stream. And with that, want to thank you very much. I think I'm like blocking it, but basically you get it. There's the Discord server. You can talk with me or follow me on Twitter and also connect with me on LinkedIn. So thank you very much and for allowing me to go over by a minute or two. So thank you again. So.
Thank you so much, Mary. It's all great.
Oh, let me kind of switch myself back to the big look.
Oh yeah, now you're big again. So hey, Mary, how you doing? So thanks a lot. It was awesome. We have some some comments here. I think you answered all the questions, Mary.
Sure.
But Vincent says thanks, really interesting. Sebastian, thanks a lot for the insightful session, Mary. James said imagination here, right? So some imagination.
Thank you.
Right. So lots of comments here. So thanks a lot. I don't see any questions. So
Okay.
I think that's it, Mary. So some people are clapping here.
Oh,
so
thank you.
Mary, it was great to have you here in the JConf, the Java Champions Conference.
Thank you.
And thank everyone for participating.
Thank you, Bruno. Thank you, everybody. Again, I really appreciate you having joined me today. Thank you.
Yes. Thank you so much. So, guys, you can go and watch the other sessions. If you're watching this recorded, remember that's on our YouTube channel. You have all the sessions from this year and all the past years too that you can come and enjoy. So don't forget to like, subscribe, and participate with us on the Java Champions Conference. Thanks a lot, Mary. Thanks, everyone.
Thank you. Okay. Bye. Bye.